Okay, good morning. So in the last lecture, we have started this aerated concrete. So before that, we have started the unit number 4, that is the special concrete. And the unit number 4, we have to learn the various types of special concretes we are using for the various project of civil engineering nowadays. So that special concretes are a very important concretes we are nowadays manufacturing and we are using. So at the start we have started the first type of concrete, that is the lightweight concrete. Under this lightweight concrete, this aerated concrete we have seen in the last lecture. So we will brush up the part of the last lecture in within the 10 minutes, and then we will move towards the whatever we have done in the next type of the concrete. So the aerated concrete is, as I told, the this aerated concrete is made up by the introducing the air or gas bubbles. So in the concrete we are introducing the gas or air bubbles, so that the volume of the your concrete will be increased, and due to that the weight of concrete will be reduced. So self weight of concrete will be reduced, and also the weight of dead weight of the concrete will be reduced. So that the concrete will be get economical, and the cost of the construction is also reduced. So that is the aerated concrete. So we can also call it as a gas concrete, or we can also call it as a foam concrete or cellular concrete to this aerated concrete. So this we have seen in the last lecture. Then some of the applications also we have seen the aerated concrete. So the aerated concrete we are using in the load bearing masonry wall using cellular concrete. Then we can use the this particular aerated concrete for the partition walls also. We can construct the precast composite wall and floor panels also for the of the aerated concrete. Again, we can filler wall in the foam or precast or reinforced panel in high-rise building. We can construct by using this aerated concrete. Again, we can construct the precast floors and roof panels in types of buildings. So in various types of buildings, we can use the precast floor. So that precast floor, why we are using this aerated concrete? Because the lightweight of concrete we have to use, as that is the aerated concrete. And so we can again use the roof panels also. So this is the some very precast components we are using by these aerated concretes. So if you see here, the if you see image, the what image saying? Image is showing the air gaps or bubbles, gas bubbles. You can see in this particular picture that is the aerated concrete. It means this is the lightweight concrete. So the next type of concrete under the lightweight concrete is the no fine aggregates. Sorry, no fine concretes. So no fine concrete, it means we are omitting the fine aggregates from the concrete. So the general concrete is a mixture of what? Cement, sand, aggregates, and water. But here we are not using the fine aggregates. That is the fine, no fine concrete. It means we are not using the fine aggregates. It means sand we are not using. So that is the no fine aggregate. So why we are not using the no fine aggregate? So whatever actual voids of the 30 to 40% we can minimize by using the this particular fine aggregates. So generally we are using only cement and aggregates. So cement and aggregate we are using in the proportion of, here if you see this is the proportion 6:1 to 10:1. This is the aggregate cement ratio. So aggregate is having 6 and cement is having 1. So 2:10 to 6:1 to 10:1. So this is the aggregate cement ratio we are considering for manufacturing of this no fine aggregate concrete. And for this the consistency will be varies between the 0.38 to point. So water cement ratio will be from 0.38 to 50. So this the strength of the snow fine concrete is dependent on the water cement ratio and aggregate cement ratio and the unit weight of water. So if we omit the fine aggregate, what will happen? If we omit the fine aggregate, the unit weight of the structure will be reduced, or unit weight of concrete will be the reduced. That is the no fine aggregate. So again, if we minimize the this, or if we omit the fine aggregates into the concrete, then the density of concrete will be reduced by, and that density will be the 1600 to 2000 kg per meter cube. So generally, the density of conventional concrete is the 2400 to 2500. 2,500 kg per meter cube is the range of the conventional concrete. But this concrete we are using the lightweight concrete, no fine aggregate. It means we are omitting the fine aggregate. It means the fine aggregates we are not using. So the weight of the concrete will be reduced. That is the 1600 to 2000. So again, the strength of this concrete will be the 15 Newton per mm square have been attained with the no fine aggregate. So we will get the strength up to the 15 Newton per mm square. Then for more grade, if we have to require the 20 Newton per strength mm square strength, then 25 Newton per 30, then we cannot use this lightweight concrete. Are you getting? So this lightweight concrete we are using up to the 15 Newton per mm square strength. So this is the no fine aggregate. So if you see here image, so the next type of concrete is the high density concrete we have seen in the last lecture. High density concrete. So lightweight concrete we have seen. So next type of concrete is the high density concrete. So we can call as a high density concrete as a heavy weight concrete also. And this here high density concrete is produced by replacing the ordinary concrete by the material to very higher specific gravity. So generally the specific gravity of the aggregate is from 2.6 to 2.9. The aggregate of specific gravity of the aggregate is from range normal aggregate is 2.6 to 2.9. But whatever aggregate we are using for the high density concrete, so we are using the specific gravity of that aggregate, that is the 4. So it means the heavy rock we are using for rock means whatever aggregate we are preparing for from the rock, that rock density of rock is higher. And so these particular types of rocks are the barium sulfate rock, and it has a specific gravity is a 4.1. So barium sulfate rock having a 4.1 specific gravity, and that specific gravity aggregates we have to use. So then these natural heavyweight aggregates we are using, that is the magnetite, limonite, hematite, and geothic have been used also. So if we use these aggregates for the high density concrete, so then the density of concrete will be increased, and that density of concrete will be 3000 to 3900 kg per meter. So 3000 to 3900 kg per meter cube is the density of concrete, and then that density of concrete will be that density of aggregates we are using, concrete we are using, and that concrete is called as a high density concrete. Why we are calling as a high density concrete? Because the density will be the normal conventional concrete density is up to 2.2500 kg per meter cube. But here the density we are increasing due to this higher specific gravity aggregates we are using. So the density will be the 3900. So again, if we talk about the high density concrete, this high density concrete generally we are using in the nuclear power plant, or where the we have to protect from the X-rays, gamma rays, Q1 or neutrons. So where heat is there, so heat is there. Where heat is there? In the nuclear power plant, heat is there. So whatever concrete we are making there, the high density concrete we are making there. Then some biological hazards, radiations arises from the fact of the radiation interact. So that if we protect from the some radiations, then we construct these such of high density concretes in there. Then the high density concretes is also suitable for preparing counterbalance weight for the lifting bridges and ballast blocks for ships, where the high density concrete produce the volume of concrete required to produce dead weight. That is the leading of economy. So this is the high density concrete. So if you see here, this image you cannot see, but the surface is a very the density of concrete will be the high, the surface will be the clean. There is no whites in the concrete. So the next, this was the part we have covered, that is the covered in the last lecture also. So now the mass concrete. Next type of special concrete is the mass concrete. So see, till now we have covered the two types of special concretes. First is the lightweight concrete and second one is the high density concrete. Then third is the mass concrete. Third type of special concrete is a mass concrete. So what is mass concrete? So see, the concrete placed in the massive structure like dam, canal, blocks, bridge, piers can be termed as a mass concrete. So where the requirement of concrete is high, more. So where is more requirement of concrete? In the dam? You have seen dam, concrete dam. So there is a huge amount of concrete requirement is there. Then next is the canal blocks. So some of the canal structures are there. You have seen along the canal, so many structures are there, canal blocks. So there may be a huge amount of mass concrete is required. Then bridges, pier. So if you have seen some of the big piers in the river region, which we have constructed for the bridges. So that piers constructed by the concrete, and for that mass concrete is required. Mass, it means in the huge amount of concrete required, mass concrete is required. And for that places we are using this mass concrete. So generally this concrete is particularly placed in the large open form, means open area, large open area is there, we are placing this concrete. And the mix of this concrete is harsh and dry and require the power vibrations of the immersion type for compaction. So again, this a particular mass concrete is the required for heat of hydration of cement, maybe leads to considerable rise of temperature. And in this particular concrete, the result in the extensive and serious shrinkage cracks also develop. So these shrinkage cracks can be prevented by using the low heat cement and continuous heat. So placing of this particular mass concrete in a small lifts and allowing several days before the placement of the next lift of the concrete can help in the dissipation of the heat. And again, this particular mass concreting, the concreting can be done preferably in a winter season. So this mass concreting done preferably in the winter season, because the peak temperature in concrete can be allowed, or as an alternate, the aggregate may be cooled and then used. So aggregate should be cooled and then we have to use. So this circulation of the cold water through pipes poured in the concrete mass may prove the useful. So this particular mass concrete developed the high early edge strength, but later edge strength in the lower than that of the continuously cured concrete at a normal temperature. See, this mass concrete gives the high early edge strength, but the lower than that of the later edge strength is than that of the cured concrete. So the curing process is very lengthy. Here the curing process is not um, uh, observed because of the mass concreting is there. So the concrete, whatever concrete water we are giving to the concrete, that water is not sufficient because of mass concrete. So the strength whatever will be developed will be more, but lead strength will get to this concrete. And there is a negligible change in volume in this in the case of the mass concrete during setting and hardening, but large creep may occurs the later age. So if you see here this picture, the mass concrete, what is this? This is the dam structure, and here the whatever concrete is there, that concrete is the mass concrete. It means what? So very large quantity of concrete we have to place in this particular area. So next type of concrete is the plum concrete. So mass concrete is also over. So what is plum concrete? So the actually the original idea of this use of the aggregate as an insert filler can be extended to the inclusion of the large stone up to the 300 mm size in the normal concrete. And the apparent of this concrete for the given amount of cement is increased, so that the result called as a plum concrete or a cyclopene concrete. So what is this? So use of aggregate is an insert filler can be extended to inclusion of large stones up to 300 mm size of the normal concrete. 300 mm size of the normal concrete, the aggregate size we are using in this particular plum concrete, we are calling as a plum concrete. So these large stones are called as a plums. So generally the aggregates we are using into the concretes, that aggregates are the up to 10 mm, 20 mm size aggregates we are using. But here we are large stone aggregates we are using, that we are calling as a plums, PLUM, plums, and used in the large concrete mass, where the mass concrete we have to use there, this plum concrete where we are doing. The volume of the plum should not exceed the 20 to 30% of the total volume of the finished concrete, and they have to be well depressed throughout the mass. And actually this is achieved by the placing layer of normal concrete, and then the spreading the plum the following by another layer of concrete, and so on. So the plum must have no adhering coating here required. Otherwise, discontinuous between the plum and the concrete may induce cracking, etc. So this is about the plum concrete. So if you see here, some of the stones we are providing into the concrete than the our 300 times mm on the aggregate, on the concrete for the replacement of aggregate. So this is the plum concrete. So next and very important type of concrete is the fiber reinforced concrete. So we can see here special concrete, various types of the special concrete. So lightweight concrete we have seen, high density concrete we have seen, that is the heavyweight concrete. Then the plum concrete we have seen. So now next is the fiber reinforced concrete. Mass concrete also we have seen. So now next is the fiber reinforced concrete. This is the again special type of concrete. So what is fiber reinforced concrete? So generally in conventional concrete, the micro cracks develops even before loading because of the drying shrinkage, and other causes of the volume change. So microcracks develops even before loading because of drying shrinkage and other causes of the volume change. So this is the very important sentence we should know before we should know the before we know the fiber reinforced concrete. So microcracks are developed even before loading because of drying shrinkage. So shrinkage will be happen, and due to that shrinkage, the cracks will be developed on the concrete in the conventional concrete. But when the structure is loaded, the microcracks open up and propagates. Then the development of such microcracks in main reason of the inelastic deformation in the concrete. So the inelastic deformation in concrete will develop in the conventional concrete. So this weakness is there of the conventional concrete. So the weakness can be removed by inclusion of small closely spaced and uniformly dispersed fiber into the concrete. So that to remove this weakness, which weakness of concrete is there? The weakness of concrete is a what? Microcracks. And this overcome to this problem, we have to use the fiber into the concrete. Why? To remove the cracks, whatever cracks generated on the surface or whatever cracks developed in the surface in the concrete due to the shrinkage, that we will minimize by using these fibers. And in addition to, of the fiber concrete, sustainability improve that it's the statics and dynamic properties also. So these fibers increase the resistance to crack growth. Why we are using the fibers into the concrete? To resist the cracks growth through by the shrinkage, and through cracks attending mechanism can improve uh, tensile strength and ductility of the concrete. If we use the fiber into the concrete, the tensile strength of concrete will be increased. So the tensile strength and ductility of the concrete will increase by adding the fibers. So again, if we talk about the fiber reinforced concrete, the fiber reinforced concrete, that is the FRC, fiber reinforcement, can be defined as the composite material consisting of concrete and discontinuous, discrete, uniform, depressed fine fibers. See how we can define the fiber reinforced concrete. So fiber reinforced concrete is a composite material consisting of concrete and discontinuous, discrete, uniform depressed fibers, fine fibers. So fine fibers we are providing into the concrete to discontinuity of the concrete, discrete in concrete or uniform concrete, to make the uniform concrete. For this purpose we are using this FRC. And the continuous meshes or woven's fabrics and long wires or rods are not considered to be discrete fibers. So the inclusion of the fiber into the concrete and shotcrete generally improves the material properties like ductility, flexural strength, toughness, impact resistance, and fatigue strength. Also we can increase by adding the fibers into the concrete. So again, there is a little improvement in the compressive strength also due to this fiber reinforced if we add the fiber into the concrete. Then the types and amount of improvement in the concrete strength. The types of amount is independent upon the fiber type, size and strength, and the configuration of the amount of the fiber. So which type of fiber we are using, so depends upon that your compressive strength will be the improved. So we will see in the next what are the various types of the fibers, and where we how we can use this fiber, that we will see in the next. So you can see here the sketch. So some of these like a steel, some of the fibers we are using, and that fibers can take the tensile load. So generally the concretes is weak in the tension, and we are using these particular types of the fibers so that the we can give the shape to the concrete in way as we want if we use these fibers into the concrete. So this is the FRC. So now various types of fibers which we can use into the concrete, that we will see in detail now. So see, so fiber is a small discrete reinforcing material produced from the steel. Fiber is a small discrete reinforcing material. Discrete, it means not small discrete reinforcing. So as for the not replacing original reinforcement, but it will act as a reinforcement. It will take the tensile load. Whatever fibers are we are using, that a small, not a look like a reinforcement, but acting as a reinforcement. So in somewhat percentage, they are acting as a taking as a tensile load. So we are calling as a reinforcement, and this produced from the steel also. So now polypropylene and nylon, glass, asbestos, or coir and carbon in the various shapes and types are available. So they can be in the circular or flat. So these are the some types of fibers are there: steel, polypropylene, nylon, glass, asbestos, or carbon, coir or carbon. These are the various fibers available, their shape and size. So the first type of fiber is the steel fiber. First type of fiber is the steel fiber. So generally the steel fiber is only of the most commonly used fiber. Steel fiber is a most commonly used fiber, and that generally in the round shape. That fiber is generally in the round shape. The diameter of this particular steel fiber is varies from 0.25 mm to 0.75. So it is not 1 mm, it is a 0.25 mm to the 0.70 mm diameter of this particular steel fiber. Then the steel fiber is likely to get rusted. Then the steel fiber is likely to get rusted and lose some of this its strength. So this steel fiber is likely to get rusted and lose some of its strength. So this the use of this steel fiber makes the significant improvement in the flexural impact and fatigue strength of the concrete also. So this is some of the way how to talk about the steel fiber. If we again talk about the steel fiber have been extensively used in the overlays or roads, pavements, airfields, and bridge decks. Why? Because the road pavements are two types. One is a flexible pavement and one is the rigid pavement. If we go for the rigid pavement, there will be the impact. But if we use this particular steel fiber into the concrete, then we can that flexibility of concrete will be increased because of that fibers. So that flexibility of the pavement will be increased, so that the roads, pavements, airfields, bridge decks, so these all are the uh, layer we are using for the transportation purpose, and there the impact will be there. So that impact will be absorbed by this particular fibers, and this thin shell and flooring subjected to wear and tear and cylindrical attack. So this is the steel fiber. Now, if you see this particular picture, so this picture is indicating the steel fibers, and the steel fibers in available in the market in this particular size, shape or size. So at least you may know these how steel fibers look and how the shape of fiber is looks. Why? Because all the fibers we are using for the in the concrete for the same purposes, about same purposes, but how looks it, that you should know. Again, the second type of fiber is the glass fiber. Second type of fiber is the glass fiber. So this glass fiber are produced in the three basic forms. Glass fibers are produced in three basic forms, that is the roving, strands, and woven or chopped stand mats, glass fibers. So this majorly this glass fibers, the major problem in their use of the breakage of fiber and the surface degradation of the glass by high alkaline of the hydrated cement paste. So the major problem is the breakage of this glass fiber, and that of high alkalinity of the hydrated cement paste. So this is the only the problem about the glass fiber. So the general again the glass fibers reinforced concretes, that is the GFRC, is the most commonly for the decorative applications rather than the structural purposes. So this glass fiber reinforced mostly we can use for the decorative applications and the structural purpose. So the addition of this 5% glass fiber and addition of the 5% glass fiber improvement in the impact strength of up to the 1500 percentage, 1500 percentage. So if you see talk about the impact, so it means the concrete will be strong in tension. 1500 percentage can be obtained as a compared to plain concrete. So with this, with the addition of this 2% fiber, the flexural strength is almost double. See, if we use 2%, the strength, flexural strength of the concrete will be almost double. If we use the 5% percentage glass fiber, then 1500 percentage, 1500% its strength increase. So this is the about the glass fiber. So if you see here, these are the glass fibers are there. It means the sheet is there. One sheet is prepared with this glass. So have you seen? So one or two MTech students have done doing this their PG. So they are using this glass fiber for their projects. So if you see, if you in the college, you can see they have done the some of the projects by using this glass fiber. Are very different. If you see their MTech project in our College campus in nearby the loading frame area. So you will know how looks the glass fiber. So the next type of fiber is the plastic fibers. Next type of the fiber is the plastic fiber. So now if you see about, or if you talk about the plastic fiber, so the plastic fibers such as the polypropylene, nylon, acrylic, armid, and polyethylene have a high tensile strength, thus repeating reinforcement effect. So fiber, uh, plastic fibers are polyethylene, nylon, acrylic, aramid, and polyethylene have a high tensile strength. So if you see the picture, whatever picture if you see here, so in this picture, the plastic threads are there. Plastic चे लांब थोडे थोडेसे आपल्या थोड्या एक बोटाच्या अर्ध्या अर्ध्या बोटा एवढे असे लेंथला pieces असतात प्लास्टिकचे. So if we add this plastic fiber into the concrete, so your tensile strength will be increases. Tensile strength will be increases. It will not go to the fail in early age that concretes. If we add this particular fiber, so your strength of concrete or elongation will be increases, ductility will be increases. Then the polypropylene and nylon fiber are found to suitable increase the impact strength. So again, this polypropylene and nylon fibers if we use, then it will be increased to impact strength, and their addition to concrete have shown better distribute cracking and resulted crack size. So this is the about plastic fiber. That plastic fiber increase the impact strength, and again to this addition of this plastic fiber has shown better distribute crackings and remove the crack size. So we can remove the crack size. So wait for 1 minute. Okay, so next type of carbon fiber is next type of fiber is the carbon fiber. So the carbon fiber again possesses the high tensile strength. Carbon fiber is also we are using for the purpose for the tensile purpose we are using, and the high Young modulus is of the carbon fiber, so that the use of carbon fiber in concrete is promising, but it is costly, and availability of carbon fiber in India is limited. See, the carbon fiber, if we use for the high tensile strength of the concrete, but the availability of the carbon fiber is very less into this particular in our India, and if we have to use, it will be the cost. So this is related to carbon fibers. It having high tensile strength but high cost, and it will be less availability in India. for this particular carbon fiber. So then next is the asbestos fiber. So next fiber is the asbestos fiber. So the asbestos fiber is a mineral fiber and has proved to the most successful fiber. Proved to the most successful fiber, which can be mixed with OPC. So the asbestos fiber is a mineral fiber and it has proved to most successful fiber so that which can be mixed with OPC. So the maximum length of asbestos fiber is 10 mm, but generally fibers are shorter than this. So the composite has high flexural strength. So this is about the asbestos filter. Sorry, asbestos fiber. So if you see the particular image, this is the carbon fiber. So the carbon fiber, as I discuss about this carbon fiber. So carbon fiber is costly because of this is not available in India in more requirement. So this is the costly, and this image you can see that image is the of a carbon fiber. So next fiber also we have seen, that is the asbestos fiber. So if you again see this asbestos fiber, so this is the if you see that is the asbestos fiber. So now factor affecting properties of the fiber reinforced concrete. Some of the factors which are affecting the fiber reinforced concrete. So these factors, what are the factors affecting the fiber reinforced concrete? If you see here, the factors are the important factors affecting and properties on the fiber reinforced concrete are volume of the fiber. So volume, how much volume of that fiber which you are using for the in the concrete. So that is the one of the factors which affects the properties of the fiber reinforced concrete. Then next is the aspect ratio of the fiber. So aspect ratio of the fiber, that is one of the factors which affects the properties of the concrete, fiber reinforced concrete. Then orientation of fiber, how you are placing the fiber, that is the orientation of fiber. Then size of coarse aggregate, size of coarse aggregate. So coarse aggregate, whatever we have used, the core size of that coarse aggregate is the factors which affects the properties of the fiber reinforced concrete. Then next is the workability and composition of the concrete. And last is the mixing. So the workability and composition of the concrete and mixing of the concrete, these are the again properties of the fiber reinforced concrete. So now, so next type of concrete is the this polymer concrete. So this polymer concrete part we will see in the next lecture. So today we will stop here, and we have seen this today mass concrete, then plume concrete, then this fiber reinforced concrete. These parts we have covered in today. So the polymer concrete we will cover into the next lecture. Okay, so we will stop here, but I will take attendance and then close.